This is section 13.6 and it's solving equations by factoring. So, so far we've been working on expressions. Expressions are like if I asked you to simplify 2x plus 6, or if I asked you to factor that, you could say 2 times x plus 3. These are expressions. An equation looks like this, like 2x plus 6 equals 10. And you would be solving, you can remember back from earlier math classes when you learned how to solve these. And you'd say, oh yeah, x is equal to 2. So an equation has the word, almost the word equal in it, because it has an equal sign in it. That's how I remember it. Okay, so we'll be dealing with equations in here. We'll also be dealing with using the zero product property. Yeah, that's pretty bad. I really need to get a better pen. Okay. So basically, you can read in the text on what that is, but basically what it's saying is that if you have a number and you multiply it times another number and it equals 0, then one of these or both of them has to be equal to 0. Okay? So if I put an x and a b here, they could both be equal to 0, or just one of them could be equal to 0 and it would make it true. Because like let's say x was 0 and b was 5. So is 0 times 5 0? Yes. Let's say x was 0 and b was 0. Would that make it true? Yes. So they can both be 0 or one of them. And we really are dealing with this right here, where we want to make one of them 0 and then we'll know the answers to it. So let me show you how that works. So if you have 3t squared minus 9t equals 0, you have an equation. The first thing you want to look for, and I keep saying it over and over, seems like lately, is your GCF. So what's a GCF between the first two terms? A GCF between the first two terms is 3t. If I factor 3t out of this part, I get t minus 3. And we'll put equals 0. Okay. From there, I can use the product rule and say, well, if I can figure out what makes this 0, that's one of the answers. And if I can figure out what makes this 0, that's the other answer. So if I look at just this 3t equals 0, how would I solve that? Well, I know that 3 times t has to equal 0. I can divide by 3 on each side. But you probably already thought, well, hey, wait a minute. The only thing that equals 0 is when you multiply by 0. So t can be 0. So 0 would make this whole equation true. So if I took that t, if I took the original equation, actually I should take the original equation. If I took that original equation, 3t squared minus 9t equals 0, and I replaced t with 0, I would have 3 times 0 squared minus 9 times 0 equals 0. And I'm just going to solve the left side of the equation. So 3 times 0 squared is 0, and 9 times 0 is 0, and I have to do my multiplication first, right? And that's going to be 0 equals 0. So if I come out with an answer down here that's true, does 0 equal 0? Yes, of course it does. Then I know that this is one of the solutions. The other solution, remember from the product, from the zero product property, we know that if the thing in the blue makes 0, that works. But also, if the thing in the red makes 0, then that works. So I'm going to take that binomial in the red, and I'm going to set it equal to 0. Okay, so I'm going to add 3 to both sides, inverse operations. and I get t equals 3. So that means 3 must be an answer too. So I could take 3 and put it into that original equation. Here's the original equation. And I'm going to replace all the t's with 3's. And this is going to be 3 times 9, and that's going to be 27. And 9 times 3 is 27. This side's going to be 27. And if I subtract them, I get 0 equals 0. So that worked too. So my final answer is actually 2 answers. I get 0 and 3. Both answers make that true. Let me back up for a second. Let me go back to here. The reason why we couldn't solve the equation, like this is just a normal equation, and so some of you might have been going, well, why didn't you just add 9t to both sides? I could do that. And I get 3t squared equals 9t. Okay, so then I'm stuck. I can divide by 3. Whoops. I can divide by 3, but I'm going to get t squared equals t. So that's why the zero property comes into play. The zero property helps us when we have one of those. So when we have one of those, we need to use our factoring strategies or methods. So we said that we said t was equal to 0 and t was equal to 3. So you can write it like this, t equals 0 and 3. So there's 2 answers. The reason why there's 2 answers is because we have this t squared. Not that that's a guarantee because of the squared that there's 2 answers, but if we're looking for something that makes 0, when we factored this out, we found that there was, let me put parentheses around here for a second. We found that there was 2 products. Here's a product, and here's a product. If I back up to what we were talking about, something times something equals 0, we said either one of these could be 0. Alright, so let's try a few more. So let's try this. What if it was already written like this for you? Can you see, do you see that as 2 products? So it's just like what I was saying, something times something equals 0. So we got to find out what makes this one 0, what makes that one equal to 0, and what makes that one equal to 0. Okay, so this is already factored for you, which is kind of nice. So it's almost like splitting it into 2 different problems. So you have what makes this 0. Well, that's easy, 0. What makes this 0? I know it seems silly that I'm solving it like this. It's like, well, duh, it's 1. But they're not always going to be that easy. And so I'm trying to kind of show you a method. Setting it equal to 0 and solving it might help. Because some of them won't be that easy to see right away. Okay? Not that you have to do this part on these easy ones, but I'm showing you. So my 2 answers are 0 and 1. I know that because I can check my answer by taking the original equation and seeing if it makes it true. So I'm going to put 0 in there first. So 0 times 0 minus 1, 0 times negative 1. So one of my products was 0, which 0 times negative 1 is 0. So 0 makes it true. Now I can go back and recheck with 1. So now I'm going to do it with the 1. So 1 times 1 minus 1 equals 0. 1 times 0 equals 0. Yep, that worked. So I know these are the 2 answers that make this equation true. So my answer is 0 and 1. Here's another one. What, 2? X squared equals 0. So we can't really pull out one of those GCFs because it's just one monomial, one term. But you do know that to make this true, this would have to be 0. Because 2 times anything is going to be 0. So you know that this one only has one answer. Even though that's why I was telling you, this is not a guarantee it has 2 answers. Okay, but so this has one answer. Here's another problem. How about this? T plus 3 and T plus 2 equals 0. So I gave you 2 products. So remember, this box times this box equals 0. Either one can equal 0. So I've got to figure out what makes this one equal 0, what makes this one equal 0. Well, this one, T plus 3, let's just say I didn't know that negative 3 would make that 0, okay? So I set it equal to 0, and I solve. Okay, so T equals negative 3. This one, I set it equal to 0, and I solve. Remember that you're going to have to show work anyway, so, don't try to do everything in your head. So my 2 answers are negative 2, equals. I am messy today. And negative 3. Those are my final answers. Remember, you can always plug them in, make sure they make 0. The next one, x times x minus 2 times 2x plus 1. So in this one, I have 3 different products. So let's take a look at the first one. So we're looking at 1, 2, 3. So I might have 3 different answers. So if this was 0, it would make all of this be 0, wouldn't it? Because 0 times anything is 0. So I know that 0 is one of the answers. Okay? What makes this one 0? X minus 2. What makes that 0? Well, I can add 2 to both sides. Well, 2 would make this circle 0. And if this circle's 0, you don't care about any of the other circles because they're all going to make 0. So x equals 2. So we go to this one. What makes this 0? Now this is becoming a little bit harder to just see right out what makes it 0. So use your previous algebra skills. Solve it. And then use your calculator to plug it back in and make sure you didn't screw up. In your calculator, type in 2 times negative half plus 1 and make sure it equals 0. So this problem had 3 answers to it. Okay, getting a little bit harder here. What about if I don't give you the products? Okay, again, you're going to have to factor. Wow. It's definitely nighttime. I'm not a nighttime person. You're going to have to factor. The way you know that is right there. Okay? So that's an indicator. So I'm going to pull out, of course, saying over and over and over, GCF. So I can pull out an x, and I get x plus 2 equals 0. Okay? What's going to make this 0? Well, 0. Right? What's going to make this 0? Negative 2. Done. How about this one? Y squared equals 16. So on this one, What's going to make that 0? Can't pull out our GCF, right? Or 6, oh, whoops, 16. I got to set it equal to 0 first. So this one is not set equal to 0, is it? And we've been setting them all equal to 0 using the zero product property to solve these. So we need to set it equal to 0. We need to subtract 16 from each side. And I get y squared minus 16. I can't really subtract those because they aren't like terms. And I get 0. So you had to do a little bit of work beforehand. So if it's not set to 0, set it equal to 0 before you start. Now look for your GCF or your factors, your factoring. So I can look here, and I don't have a GCF, but I know that y squared would equal y minus 4. Ooh, and I just realized something. I don't know that you would know. This problem wouldn't come up for you on 7060 because we skipped this section, which I think was like 12.4. That comes back around in E and F. So you can ignore that problem if you want. If you don't want to, if you want to look at it and you want to understand it, if I FOIL these, I get y squared, I get a 4y, and then I get a minus 4y, and then minus 16. And when I go to combine these, they disappear. And I don't know that you would have just seen that from looking here without going through that section. So we'll move on. Let's see. The next one. Oh, I hate z's. Z squared minus 3z plus 2 equals 0. So this one's set to 0 already for you, so that's good. So, do you see greatest common factor? No. So that means I must be able to factor it. So it goes back to that, what multiplies to 2 and adds to negative 3. So it goes back to last section. If it adds to a negative, that means these, and it multiplies to a positive, that means they both must be negative. Oops. Negative 2 times negative 1 makes positive 2, and they add to a negative 3. So I know it's x minus 2 and x minus 1. And I set that equal to 0, and then I can use my zero product property. What makes this binomial 0? Well, 2 would make it 0. 2 take away 2 is 2. 2 take away 2 is 0. What makes this one 0? 1. So there's my two answers. Alright, and a little bit harder. 2x squared equals 5 minus 9x. So this one isn't set to 0. But you know that we're using the zero property, and since we have an exponent greater than 1, we need to use the zero property to solve it. So I'm going to move everything over to the left. So remember, like, this is the middle of your equation. I'm going to take the 9x and move it over. I could have started with the 5. It doesn't matter. Okay. So minus 9x and plus 9x cancel. Leaves me with 5 on the right. Over here, 2x squared plus 9x, I can't add those together and call them 11x cubed. They aren't like terms. So I want the highest degree in the front, and then I want the 9x. So I'm almost there. Now I'm going to take 5 away from each side. Leaves me with 0 on the right, which is my goal. But over here, remember, none of these are like terms, so all I can do is just write them. Okay, so I'm going to write this on the next page nice and clear so that we can read it. 2x squared plus 9x. Minus 5 equals 0. Okay, so first thing you look for, GCF. Do you see a GCF? No. So the next thing I look for is I factor. Okay, so I know it's going to multiply. Oh, and these ones you don't have not done. It's going to multiply to negative 10. And actually you don't need this one because we never did it. We never factored with a coefficient greater than 1. Well, there are a few with a coefficient greater than 1. So here we go. So these multiply to negative 10. Actually, I just looked that up, and you will not be required to factor with a leading coefficient greater than 1. So you don't need that example until your next math section. And by that time, you'll be good at factoring with coefficients of 1, and so it will become easier. Let's see. Oh, applications. Two more little parts. Real life applications. Quadratics or trinomials with the degree of 2 are used in real life application quite a bit. Anything that comes up and comes back down follows the path of a quadratic. So they talk about a golf ball, and it says, and you can read the problem. It's better that you read the problem in the book, but it's right at the end of the section. It says, when will the golf ball hit the ground? And you will for sure have story problems on your final. So just applying the math, making sure you understand it. So they give you the formula, h equals 132t minus 16t squared. Oh, it's just dawned on me they wouldn't give you a problem like this because, oh yeah, they will. Okay, 16t squared, sorry about that, equals 0, or equals h. Sure. Actually, they will not give you that problem because that would be a leading coefficient greater than 1. So ignore the golf ball problem. They might give you a problem, though, without the leading coefficient being 1. Here's a different problem that they could give you. Well, it's just hard trying to give you problems that do not have a leading coefficient greater than 1. But you're lucky that you don't have to do those right now. If you had a picture, and they have this problem in the book. If you have a picture frame and the length is 20 pixels wider or more than the width, and they tell you that the area of the pixels is 2400 pixels. So the area inside here is 2400 pixels. And they want to know the dimensions in pixels. So they're saying that x times x plus 20 has to equal the 2400 because area is length times width. So it goes back to, we've done a couple problems like this now. So if you wanted to find out what x was, you could use the zero product rule and you could solve for 0. So let's do this first. Let's multiply these through and get x squared plus 20x. The reason I'm doing that is because we need to bring the 2400 over, and it needs to be in that form of a trinomial. Okay, so now we're going to bring that 2400 over. Remember, you're looking for it to be in that format that we've been dealing with in this section. So you have x squared plus 20x minus 2400. So let me write that on the next page. So now we're looking for something that multiplies to negative 2400 and adds to 20.